Hi, and welcome to week 3. I had a couple questions, so I'm going to make a video that will hopefully explain so that we can go through 3 examples together of how to determine the molecular geometry or shape of a molecule. So first, you want to open the packets that you submitted last week. I went through everybody's and made marks in green. At the end of next week, you will be submitting these packets completed, and you should be making the changes to any of the ones that I have marked in green. Those are the ones that you have a mistake on. We said last week that we were only going to be naming binary ones. So if you look at my sheet that you see, there are 2 of them I have crossed out. You are not responsible for naming those. And also, there's one of them where the shape is marked off. You should mark that one off on yours as well. On page 2, you are not responsible for naming or finding the shape for these 2 structures that I have marked off. So you should mark those off on yours as well. And then on page 3, you are just not responsible for the name for CH2O because there are 3 or more elements. We're only naming binary. So I also had a couple questions on what should go in the built column. This column would actually be for if we were in class, we would, at the end of filling in this packet, build these molecules. Unfortunately, we're not in school, so that's not an option. So your built column is going to remain empty the whole time. This is where I'm going to make marks for you to know which ones you need to fix for the following week. So we're going to start with NH3. First, NH3 has 8 total valence electrons. Nitrogen contributes 5, and I have 1 nitrogen. Hydrogen contributes 1, and I have 3 hydrogens, so 8 total. When we are naming this molecule, it is nitrogen trihydride. So I have 1 nitrogen, we never use mono on the first, and I have 3 hydrogens, so trihydride. When we draw the dot structure, nitrogen goes in the center, and I place its 5 valence electrons. I need to place 3 hydrogens. They each contribute 1 valence electron. So when I connect my singles, nitrogen is single bonded to each of those hydrogens. Now, another document that I have posted for you is the VSEPR shapes one. So when we're looking at valence shell electron pair repulsion, you care about 2 things. You look at the central atom only, and you want to know how many atoms are directly bonded to that central atom. So in this case, nitrogen is my central atom, and I have 3 hydrogens directly bonded to it. Second, when determining a shape, you look at, again, the central atom only, which is nitrogen, and see if it has any lone pairs. My nitrogen has 1 lone pair. So when I'm looking up on my VSEPR sheet, I want to look up 3 and 1. This directly matches with trigonal pyramidal. So again, I determine that shape by using the VSEPR PDF that I have posted on Schoology. I look at how many things are directly attached to my central atom, which is nitrogen. In this case, it's 3 hydrogens. And then I look at my central atom only. Does it have lone pairs? Yes, it has 1. And so I look up 3 and 1, and that shape is trigonal pyramidal. When I'm asking you to redraw it in the shape, use the picture that's all the way to the right. So trigonal pyramidal actually looks like that. The lone pair on nitrogen pushes those hydrogen away as much as possible. That's as far as you're going for today. So again, you're never going to have anything in the built column, and polar nonpolar is going to be for next week. So we're going to look at a second example on our second page. Here we're looking at C2H6. So when I'm naming, this is dicarbon hexahydride. In this case, I have two central atoms, carbons. Each of them has 4 valence electrons, and I need to then place 6 hydrogens. Each of those 6 hydrogens contributes 1 valence electron. And so when I connect my singles, carbon is single bonded to itself and each of those hydrogens. Now, when we're determining our Vesper shape, I want to see how many atoms are connected to the central atom. Well, in this case, I have 2. This is a mirror image, so whatever the shape is on one side is going to be the same as the other side. So I'm just going to choose one carbon to look at. So I'm going to look at this carbon and I want to see how many atoms are directly attached to that carbon. So I have 4 atoms connected to that carbon, 3 hydrogens and 1 carbon. I then look at that central carbon and see that it has 0 lone pairs on it. So when I look up shape for 4 and 0, this is called tetrahedral. Essentially, tetrahedral is a cross. And so I have 2 crosses attached to each other. When I redraw my structure, it's not going to change very much from the one I already had, and that is okay. So that is my finished structure for dicarbon hexahydride. It's essentially 2 crosses attached to each other. And that's what you do when you have 2 central atoms. You choose one of them to look at. So for the next 2, you are not responsible for their naming or their shapes. They are not a mirror image, and so we can't determine their shapes based off of our Vesper sheet. Moving on to our last example, we are going to look at H2O, which we know to be water, but in this case, when we're naming it, it's hydrogen monoxide, dihydrogen monoxide. So when I look at dihydrogen monoxide, I look at my structure. Oxygen's going to be in the middle, and it has 6 valence electrons. I need to attach 2 hydrogens. They each contribute 1, so oxygen is single bonded to each of those hydrogens. When I'm looking at my Vesper shape, oxygen is my central atom. It has 2 atoms directly bonded to it. Both are hydrogens. And then it has 2 pairs of valence of unshared pairs or lone pairs. So when I look up on my Vesper sheet, 2 atoms bonded to the central and 2 lone pairs, that shape is bent. And so when I redraw it, these 2 lone pairs are pushing these hydrogens. It's bending the molecule to push them away. So that is what you are completing for today. Again, your built column is going to remain empty. That's where I'm going to put in any notes or ones you need to revise. You should have the number of valence, the names, the dots, the shapes, and then redraw them neatly in that shape done. Polar, non-polar is for next week. So please leave that column blank for now. We'll do another video next week, and then you will submit this entire thing next week. And then we'll be done with this packet and moving on. Please email me if you have any questions.